Okay, if everyone could please join the Kahoot by clicking the link in the chat or just typing the pin, I'd appreciate it. So we can get started at the end of class really fast. Today we'll be learning about variables and expressions. I know some of you may have had contact with variables in my kangaroo math camp, but if you haven't touched it before or are kind of confused at what it is, I'll try and dispel any uncertainties about that, and hopefully you guys will know what coefficients, variables, and expressions are by the end of class, and we can do our Kahoot. So let's get started. All right. So do I have any volunteers who'd like to read the first example in this mini lab on the left here? Any volunteers who'd like to raise their hand? Okay, I'll start with Aiden. Can you read? All right, Jason. I see you're back with volunteering. Would you like?
Hello.
Hello. Would you like to read this section here
Yeah,
with the mini lab? Thank you.
the pattern is made up of triangles, each with side lengths of 1. Draw
Mhm.
the next 3 figures in the pattern.
Okay,
Find the
so
perimeter of.
Jason, slow down. Let's do it as the question wants us to go, as the examples want us to go. So we have, if you see on the left, we have this equilateral triangle here, and after that, we continue building the triangle, right? So it's asking us to draw the next three figures. Would you like to? Are you able to draw on the screen, Jason?
um yeah.
All right. Then please draw the next figure. Okay, so after Jason, I'll have Garrus. You can draw the one after Jason's figure, and then Ryan Lin. Can you draw after Garrus? So I see Jason's already begun. Um, so in case you don't know how to draw, use the annotate button on your toolbar, and then okay.
Oh, just like one here. It's just a bit smooshed
Okay,
up.
yeah. So in total there are four triangles, right? Are there four
Yeah.
triangles? Yes. Okay, thank you. Ryan, he's drawing the next one. Okay. And thanks, Ryan. What about Garrus? Can you finish off, please? Okay, so while Garrus and Ryan both
Why did it duplicate?
so while Ryan and Garrus are drawing, may I have
Why is it duplicate?
Ray,
Oh,
can you read question 2, please?
Find the perimeter of each figure and record your data in a table like the one shown below. The first 3 are completed for you.
Thank you. Jason, can I trouble you with drawing your figure again? Because I know it might be a bit misleading if you want to count the sides. So we see in the first figure, I will do some drawing of my own here. We see in the first figure there are 3 sides. If you just count them, 3 sides on a triangle, you have we have 1, 2, 3. Uno, oops. Uno, dos. Oh, this is having a bit of trouble. And 3 sides. Okay, well. This is, and then I'm not sure if it's working properly here, but oops, my bad. Sorry, guys. Um, so we see in the first figure, there are 3 sides to the first triangle, and then for the second figure, there's a perimeter of 4. The fifth figure, there's a perimeter of 5, and I think Jason is drawing the fourth. And how many sides does your figure have, Jason? Can you tell me how many sides it has, or like the length of your figure?
Okay, just like
You can write on the screen.
4.
You think there are 4? So yes, there are 4 sides, but if you look at the examples, especially I think number 3 over here. Okay, this is not working very well for me today. But if you look at figure number 3, you'll see that one side is longer, right? The base side has
Oh, 6.
2. So exactly. Your figure has a length of 6. It has 2 on the top, 2 on the bottom, and 1 on each side. So that's 2 plus 2 plus 1 plus 1. You have a total length of 6. So over here, oh, okay. I'm gonna have to do a bit of the annotate. So over here, for number 4, the empty box under number 4 for perimeter, can you fill in 6 for that, please, Jason? In the mini lab. So over here.
You call my name?
Yes, can you fill in can you fill in this one, please?
Okay. I didn't hear you. Sorry.
Okay, so that's a 6. And then we see next, I think
Did I do it right?
yes, you would fill it in that way. So we see for if there are 5 triangles, if let's say this one of the red ones, so someone drew an arrow. Thank you to the person who drew the arrows. For the 5 triangles, we see it has a perimeter of 7. You can count them. One, can you guys see my mouse?
Yeah.
Yeah. So we have 1, 2, 3, 4, 5, 6, 7. I think Jason filled it in as 7. After that, for the 8 triangle one, there's 1, 2, 3, 4, 5, 6, 7. I think this is a total of 7 triangles. So this one, um, the 6 triangle one, it would have a perimeter of 8. Okay. I appreciate everyone who drew the triangles on the screen. But let's continue with the third part of this mini lab. And now I see we've been drawing quite a lot of triangles, quite a bit more than was expected. But if there are 10 triangles, what do you guys think would be the perimeter? So I'm gonna clear the screen for a second. Is there anyone who hasn't volunteered yet so far? Ryan, would you like to
12
guess?
triangle.
Would you like to guess for 10 triangles, what is the perimeter of the figure?
12 per meter.
Yes, it would have a perimeter of 12. We're not too sure how long it is because there's no units given, but the perimeter would indeed be 12. So would you like to check it by drawing a 10 triangle figure, please, Ryan?
Okay.
You can start from the left side. Okay. So while Ryan is drawing his 10 triangles, Ryan Lin, can you tell me what is the relationship between the number of triangles and the perimeter? Can you think of anything? Any relationship? Ryan Lin? Okay, thank you, Ryan. I'm pretty sure this is 10 triangles, 5 triangles on the bottom, 5 triangles at the top. And we see that there are we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it does seem like we have a perimeter of 12 for a 10 triangle figure.
Easy.
Do I have any volunteers who would like to tell me the relationship? So let's say I gave you a really big number. So instead of 10 triangles, let's say give me a 100 figure. Let's say I give you a 100 figure, 100 triangle figure, and I asked you to find its perimeter. What would be its perimeter? How would you calculate that? You don't need to draw it because 100 triangles would take a long time to draw. Jason, are you guessing 120?
Yeah.
Yes.
Because if we have 10
Mm-hmm.
and it's 12, and then 10 times 10 is 100. So we
Mhm.
just times 12 by 10, which is 120.
Okay, so you think it's 120. So if I give you 100 triangles, um, like if I just gave you the number 100, okay, how would you take 100 and hop to 120? What would be like what would your like how would you step from like where would you leap from 100 to 120?
Eh, what? Do you
So
mean?
if we look at the patterns so far, Can someone please clear the screen, please?
Wait, 12? 12 is 10,
If we
right?
look at Jason, if we look at the patterns, if you only had one triangle, it has a perimeter of 3, right? So from 1 to 3, do you see a difference? What's the
2.
difference between, there's a difference of 2, exactly. How about from 2 to 4?
2.
There's a difference of 2. What about from 3 to 5?
2.
2. And then I'm pretty sure you filled in 6, 7, 8 for the bottom. Do you mind filling that in again, please?
Okay.
Okay, thank you. So from 4 to 6, what will you need to add?
2.
2. 5 to 7,
2.
good. And 6 to 8,
2.
2. So if I continue going down the line, 7, 8, 9, 10, so on, all the way to 100. From 100, if I gave you 100 triangles, what would be its perimeter?
Added by 2.
Add by 2. So 100 plus 2 is
102.
102. Now, instead of 100, what if I jumped all the way to 1,000? What would
1002.
1,002? What if I gave you a million?
1,000.
1 million.
A
and
million.
A million
two.
too, exactly. So we're seeing the pattern here, right? If I gave you some number of triangles, you know that you need to add 2 to get its perimeter. No matter what number I
now
give,
get it.
yeah, you see, no matter
We
what
just
number I
only
give,
add 2. We don't.
you would only need to add 2, even if it's ridiculously big, because a million, it's a pretty big number. So if you just continue drawing triangles like that, you'd spend your entire life and you wouldn't be able to find out. But if you just know the pattern, very easily, you just know, oh, 1 million plus 2, that's it, 1,000,002. So that's that. Now that we're done the mini lab, let's move on. Do I have any volunteers who would like to read this next section, please? So starting with in the mini lab. Thank you, Ryan, for the pointer. Aaron, can you please be so kind as to read this section, please? So starting with in the mini lab.
In the mini lab, you found that the perimeter of the figure is two more than the number of triangles. You can use a placeholder or variable to represent the number of triangles. A variable is a symbol that represents an unknown quantity.
Okay, thank you, Aaron. I'm pretty sure if any of you have taken some of the coding classes FutureEd is holding, you'll notice that variable will be coming up a lot. So variables, their numbers, you're not too sure, right? It can be this, it can be that. It's variable. That's where the name comes from. You don't need to know what a variable is, but if someone fills it in, then you can find the perimeter of the figure right away, right? So if I gave you an example of, say, a billion this time, Aaron, can you tell me what would the perimeter of the figure be if I filled in 1 billion as the variable?
Wait, 1 billion, 1 million.
1 billion, a billion with a B.
1 billion, 2.
Exactly. So it doesn't matter what number I throw in for n, like 1 billion, a trillion, whatever number, a Google, whatever, you can throw in. That variable, it'll hold it. And then you can calculate the perimeter of the figure just by adding 2, right? Please continue, Aaron. So starting with the branch of mathematics.
The branch of mathematics that involves expressions for variables is called algebra. The expression n plus 2 is called an algebraic expression because it contains variables, numbers, and at least one operator.
Okay, so we see quite a few new terms here. I know algebra sounds like a very foreign term, and I'm pretty sure it actually comes from it has Arabic origins from some dude. He wasn't the person to invent algebra, but he came up with a word, and he had like I think a 16-chapter book or something with all sorts of ways you could manipulate numbers. And algebra, it is the science of manipulating numbers. So we're going to get started, all right? So now we've already tried n plus 2. If I gave you a million, a Google, or anything, you can fill in n plus 2 is a million plus 2 or a billion plus 2. So now let's look at if I gave if we have the expression n plus 3? I'll scroll up a little bit. I think you guys already saw the answer. But so Ada, can you tell me what n plus 3 would be if n is equal to 4? Ada? Okay, if Ada isn't present, do I have any volunteers? Okay, I think Ryan at the bottom put positive 7. Okay, so how do you get 7, Ryan? Can you turn on your mic, please?
Wait, what was the question?
So the question is asking for evaluate n plus 3 if n equals 4.
Oh, then that's 4 plus 3 because
Mhm.
n equals 4 and 4 plus 3.
So in terms of algebra, when someone gives you an expression like n plus 3 or anything really, we can usually do it like this. So let's say you have an expression. You have n plus 3. And then now I say n is currently equal to 4. Or I just tell you n is equal to 4. So in this case, we can cross out n. We can throw in a 4. So you guys should all know what 4 plus 3 is. And 4 plus 3 would be 7, right? So what if instead of 4, Ryan, can you stop scribbling on the screen, please? What if instead of 4, I threw in, let's say 10, okay? So instead of 4, I threw in 10. Can someone tell me what n plus 3 would be equal to? Ryan, or Jason. I'll let Jason take this one.
13,
So why is it 13, Jason? Can you can you tell
because n equals 10.
Okay, so 10, if I substitute it in, that's what it's called. If n actually has a value, in this case it would be 10, right? You would substitute it in. So you would put 10 plus 3. And
But if it's n plus 3 equals 10, then n
Mhm.
equals 7.
well, okay, that's another case. That would be how you would solve for n. But right now, we're substituting n into the expression, right? So it's like if you have a normal teacher, and then your teacher one day calls in sick, and then someone else comes in, right? So in this case, let's pretend I'm currently your teacher right now, all right? But then I call in sick, and then someone else comes in, and just someone
Me.
else is a 10, right? Okay, let's say Jason comes in. Jason is a
Hooray!
10. He comes in, and now he's the new teacher. So n would be substituted by a 10. So myself, I'd be substituted by Jason, and then 10 plus 3. You guys, what is 10 plus 3?
13.
13. Thank you. So the substitute teacher, or Jason, 10 plus 3 would be 13. What if instead of Jason, we substituted something else in? Let's try
Me.
Okay, Ryan. Let's say Ryan is a 20. This has no numerical meaning. So if it's 20 plus 3, we substitute n for 20. What is 20 plus 3? It's not 40, Ryan. So what's 20 plus 3?
33. I mean, I want the number 40.
Okay, well, in this case, I just put n equals 20. So if n equals 20, 20 plus 3 would be 23, right? So the expressions don't always need to be addition, as we will see in the next few examples. In this case, we see that if you want to evaluate n plus 3, if n is equal to 4, you would simply replace n. You have the n, and you go like, switch and bait. Ha, now it's a 4. So 4 plus 3, you smash it together, it's a 7. So you get 7 as the answer for this first question. Okay. Sean, would you like to try A? So the check your progress. Can you try A, please? If C is 8 and D is 5. What would C minus 3 be?
5,
C, okay, why is it equal to 5?
because C equals to 8.
C equals, yes, so C is equal to 8, and then 8 minus 3 would indeed be equal to 5.
Yeah.
Okay. So, can I have another volunteer who would like to do B? 15 minus c if c is equal to 8? Okay, Ray, go ahead. So what is 15
I'm doing
minus-
B, right?
Yes, you're doing B. So 15 minus c if c is equal to 8.
So,
So the first step,
it's 7.
exactly. The first step, you would substitute the 8 as into the c, right? Because the c is equal to 8, so 15 minus 8 is indeed equal to 7. What if, now we had two variables. We have c plus d. Ray, would you like to try it again? What is c plus d if c is equal to 8 and d is equal to 5?
It's 13
Exactly. So why is c plus d equal to 13?
because C is substituted by 8 and then
Mhm.
D is substituted by 5.
Perfect. I think you're getting what we're doing here. So, as we see, even if it's two variables, it could be 3 variables, 4 variables, 100 variables. You might see like in math contest, they'll give you like 20, 23 variables, because that's the current year. But you know, it doesn't matter. You just take all these values, throw them in, and then out pops your answer. That's kind of what we're doing here. We just take the values, plug them in, and out goes the answer. So, you guys will probably see this very often, but in algebra, the multiplication sign is often omitted. And would someone like to guess why the multiplication sign is often omitted? Well, so first of all, what does the multiplication sign look like? Would you guys like to draw it on the screen? Okay, I see Jason, Ryan, you guys are all drawing lots of X's on the screen. And I'm pretty sure for historical reasons, lots of people like using X for variables. So variables, they can be any number, they can be a cupcake, they can be a star, but for some weird reason, everyone loves using X. And unfortunately, the letter X looks a lot like multiplication, right? So if I write something like 6, okay, if I write something like, if I write something like this, 6, 6x 5x equals something. You have no idea what I'm putting here. You might be like, hey, even you missed something. Or you might be like, what's the x? Is this an x? Is that an x? You have no idea. Which is why in multiplication, in algebra, we sometimes substitute multiplication with a dot, okay? So you might see something like 6.5. This is the same as 6 times 5, right? Jason, can you please refrain from scribbling on the screen? So instead of the usual 6 times 5 where you put an x, you would, well, some people would just put 6.5, right? That way it's less confusing, and you know that 6.5 it's just 6 times 5 or 30, right? The dot, it has other meanings, but for our purposes, it's a more clear way to show that it's multiplication and not like a variable x. Okay, because if you start throwing in numbers, multiplication signs, and letters, it gets really messy really fast, which is why when you do algebra, if you have 6d, that would simply be 6 times d. There's no 6xd. Otherwise, you have no idea what it means. Similarly, 9st, mn, they mean 9 times s times t, or m times n, respectively. Okay, and we're going to be learning something called the coefficient. Do I have any volunteers who would like to read this section, please? Okay, William, would you like to read this section? Or Ryan Lin, can you read this section, please?
Number cofactor.
Oh, okay, I'll let William read since I caught up to him first.
Multiplication.
Mm-hmm.
And expression that contains a variable is called a cofactor,
A coefficient.
the coefficient.
Mhm.
Coefficient of 60.
Is the coefficient of 60. Thank you, William. So let's try some examples. Instead of doing the questions, William, can you tell me what is the coefficient of 8W? William?
8W.
So what is the coefficient of 8W? So, okay, I'll do an example first. If you look at 9ST, you see some letters and you see some numbers in this expression, right? And when I'm asking for the coefficient, you just want to see the number part, okay? And in this case, the number part would be 9. So if I asked you, what is the coefficient of 9ST, you would tell me the coefficient is 9, okay? For MN, it's a little bit confusing because it looks like there's nothing. You might say 0, but actually there's an invisible 1. I know I've had a lot of math teachers who would say, if you see like an MN or just a lonely X, you can, if you want, just put a 1 in front of the MN. So let's say instead of like an X over here, say I have an X, the invisible coefficient in front would be a 1. Okay. If your number is negative, for example, let's say we have negative y, the coefficient, there's also an invisible 1. So in this case, the coefficient would be negative 1y. So the coefficient will be negative 1, because that's the number, the numerical part of this expression, okay? So let's say, Jason, would you like to try this example where, if I asked you, what is the coefficient of 8W?
8 times W, maybe.
So the coefficient, remember, if I gave you 8W, okay, you want to look for the number within this expression, right? So W, is it a number?
Hmm?
So W is a
W
letter.
is a number.
The W is a letter, right? Or it's a variable. It's the variable of the expression. That means it can change. But 8, it's just a number. You know 8 is 8. It's this much on your fingers, right?
Yeah.
So in this case, the coefficient would be 8. Okay. So if I asked you what is 9V, oops,
With 9B,
the
the 9 is the
coefficient of
9
9 would be the coefficient. What about 67A? What is the coefficient?
67.
67. So 67 would be the coefficient. Ryan, can you tell me what is the coefficient of 102 CD?
102.
102 would be the coefficient. See, I'll ask Nicole, can you tell me what the coefficient of 87 MN is? Nicole, what is the coefficient of 87 MN? Okay.
Wait, for 87 mm?
Mm-hmm. So what is its coefficient? Or the numerical part, not the variables. So you see that M and N, they're both letters, right? But 87, it's a number. So 87 would be the coefficient of 87 MN. Do you see that, Nicole? Okay, I'll try another example. What about, let's go with 54. 54Z. What is the coefficient? Nicole? So we see that Z is a letter, right? It's the variable. but 54, it's the coefficient because it's the constant numerical part of the expression. All right. So you'll actually see coefficients a lot, especially in chemistry. You might have like five some element plus some other element becomes some other element. Well, okay, I might be confusing you guys, but you will see coefficients a lot if you learn sciences, especially chemistry. It's used a lot in chemistry, and math in general, really. So let's take a look over here. Okay. Jason, can you read question 3, please? I'm gonna skip question 2 because of time constraints.
Calculate 4y to 2 if y equals 3.
And Jason, we pronounce this as 4y squared, okay?
4y squared.
2
Oh
is
yeah,
an
because the
it's
2
a
is
power.
an exponent.
Exactly, it's an exponent. So we pronounce it 4y squared plus 2 if y is equal to 3. So I'm gonna cover this up a little bit.
4
I haven't probably already.
times.
Mhm.
Wait,
So
can I do it?
go ahead.
So if y equals 3, we can write it here.
On the whiteboard?
Not anywhere.
Okay, I'll write on the. You can write on the whiteboard then.
If it's 4,
Mhm.
and then can I see the question?
Okay, I'll write it out. So we have 4y squared plus 2, and we're given that y is equal to 2. Okay, that looked a little like an x, but
Okay,
y is
then
equal to 2.
4 times
Mm-hmm.
2 equals 8.
Okay. And then
And then the 2, I mean like the, wait, oh, I did something wrong.
oh, okay. Well, if you haven't noticed, I have bed miss written out here. So
Yeah, I know. It's
you
4
don't see any
times,
brackets. Mm-hmm.
is this.
Yes, it is written as 4 times y squared. And remember, we in algebra, we don't like writing the multiplication sign. So instead of an x, you can just put a dot, okay? You can just write a dot over here. All right? So okay, I see you've calculated 2 squared is equal to 2 times 2, which is 4. And then 4 times 4 is 16. What next? Is that it, Jason?
Oh, plus 4.
Plus what?
I mean, plus 2.
Plus 2, okay. So what is the answer?
18.
Exactly. So in this case, the answer will be 18. And if you were to write this, for example, on a test, you wouldn't really want to write giant crosses like this because, as I mentioned earlier, the multiplication sign, it looks a lot like an X, right? So if I'm reading this, I'm like, oh, 4xy squared plus 2 equals, what's X? I have no idea what X is equal to, but there actually is no X, right? So in this case, you want to avoid writing multiplication as an X. So if I were to rewrite this, do you mind? Okay. So if I were to write this, for example, on a test, I would try doing it. Oops. Okay. Oops. Okay. So on a test, you try doing it this way. All right. So you would rewrite the question with the variable put in. So we know that y is equal to 2. So in this case, we can simply fill it in like this, right? Instead of y, we can just replace it with brackets and then throw the little number inside. So 4y squared would be written as 4 times 2 squared plus 2. Okay? That's how we would substitute the 2 into the expression. After that, what do we do first? We have brackets, right? And then we have exponents. What do we have an exponent in this question?
Yeah,
Yes. So what's 2 squared?
4.
2 squared is 4. So in this case, we would have 4 times 4. Notice I didn't write an X or a cross. I just put a dot. So 4 times 4 plus 2. And what's after exponents? We're done with the exponents. Are there any
16
division?
times, it's 4 times 4.
It's 4
and
times
6
4 because there's a multiplication sign, right? The multiplication sign in this case is a dot.
I
So
mean,
4 times-
if there was a division, the multiplication it still would go first because you're doing it in order.
exactly. We're doing it
Multiplication
from
or
left to
division
right.
is okay.
Yeah, they're on the same level. So right now we have 4 times 4, which is 16, as you said, plus 2. And in the end, we get the final answer of 18. So when y is equal to 2, this expression is equal to 18. Let's go back to 8w minus 2v, okay? So 8w, we rewrite this, 8w minus 2v. Can I have another volunteer other than Jason? Work this out for me, please. So we have w, I think is equal to 5, and v equal to 3. Ryan, go ahead. So how would you write this?
So we're just gonna write it like this, like no, actually just a dot instead.
Yes, just the dot. I'm glad you caught yourself. So 8 dot, or 8 multiplied by 5 minus 2 multiplied by 3. Okay, and then we're home 3. So 8 times 5 is 40, 2 times 3 is 6, and 40 minus 6 is equal to 34. Good job. And I know on most teachers, they will mark this correct, but some people, they might be very strict, and they'll tell you you need to substitute the values in first. So in this case, instead of just putting 8 times 5 minus 2 times 3, you can put 8 brackets 5, right? And then minus 2 brackets 3. Okay, something like that. It's not necessary, but if you do ever meet a teacher who's like, write out every single step, just remember you can make sure you don't lose any marks by substituting the values in one by one. If you're really short on time, you can do it the way Ryan just did it. But if on a test you really want to make sure you're substituting in values correctly, then just make sure you throw in the brackets properly, and then you should be fine. All right. Okay, so thank you, Ryan. Let's go with another example before we start the Kahoot. Okay, we have a real world example now. So, okay, I don't think we've covered this before, but the fraction bar is a grouping symbol. Evaluate the expressions in the numerator and denominator separately before dividing. Okay, so this is, I think, a little exclusion from our usual bedmess. So let's say I gave you this expression, all right? Let's say we have this expression. We have 8w squared plus 3 over w minus 4, okay? And let's say w is equal, actually, I don't think this is a very good example. Let's say this is a squared, and then I'm gonna get rid of this. So, okay, yeah, this might be okay. Let's say w is equal to, let's just go with 1, all right? Let's make the example easy. So w is equal to 1. How would we evaluate this? 8w plus 3, all of that divided by w squared minus 4. Any volunteers other than Ryan and Jason? Okay, well, I guess it's you two again. I'll ask Ray, would you like to give this a try? Ray, are you? Thank you.
Wait. Which one?
So the question on the screen, we have 8w plus 3 divided by w squared minus 4, and then we have W is equal to 1. How would you calculate it? Right?
I don't really know.
You're not too sure?
Yeah.
Well, in this case, remember, we can just substitute every single value in, all right? So, if, let's say, we have 8 times 1, right? Because W is equal to 1. So we can substitute 1 into the expression. 8 times 1 plus 3, all of that divided by 1 squared minus 4, right? So how would you simplify this, Ray?
So 8 plus 3 equals 11.
Okay, so you would do 8 times 1 is still 8, plus 3 is 11. And what about on the bottom? What is 1 squared?
I forgot what the square means.
Okay, so a square is the same thing as an exponent. And I know that that might not mean anything to you either, but 1 squared is the same thing as 1 times 1. Okay, so if I gave you something like what is 1 cubed, it would be 1 times 1 times 1. Okay, if it was 1 to the 4th power, it would be 4 ones multiplied by each other, right? 1 times 1 times 1 times 1. So in this case, what is 1 times 1?
1 times 1 is 1.
1 times 1 is 1. So what is 1 minus 4?
-3.
Negative 3. Oh my, a negative. So we have 1 minus 4 is negative 3. Okay, so we have negative 3. And then we have 11 divided by negative 3. Can someone convert this into a mixed fraction, please? Jason? Would you like to convert this into a mixed fraction?
What?
So, oops.
Or like
Can you
like-
convert?
-3 into -3 and
Okay,
11.
maybe let's make this a little bit easier. So instead of plus 3, I'll make this plus 4. So 8W
I
plus
know. I mean,
4.
I know how to do it. I know how to do it.
Oh, okay, but just for the so we get whole numbers instead of fractions. So 8 plus 4 is 12, and 12 divided by negative 3. What's 12 divided by negative 3?
-4.
Negative 4. Okay, so we see here that the final answer will be negative 4. And if you look at what we did, if you look at what we just did, first we did the multiplication, right? Or actually, the first step we did was we substituted every 1 into every W. So every time we saw a W, we're like, aha, that's 1. So 8W, we switch out the W for 1, so that's 8 times 1 plus 4. You notice that we didn't exactly follow Bedmans here, right? We're supposed to do exponent, division, multiplication, that sort of stuff first. But after we substituted in, we just did the addition on the top, and then we just did the subtraction on the bottom, and we did the division last. So the division, the reason it's done last, if you remember, in the textbook over here, I'm having a bit of trouble here. It says the fraction bar is a grouping symbol, and whenever you see a giant fraction bar, you want to evaluate the expression on the top and evaluate the expression on the bottom, or the numerator and the denominator. You want to evaluate them separately, and finally, the last step would be dividing them. Okay, so I know you might have noticed we didn't. You might say like, hey, even we didn't divide it right away, but when you see a giant division sign like this, a giant fraction bar, you do want to finish the top, finish the bottom, and then do the division. Okay, that way it should come pretty naturally, I think, because if you have like a really complicated expression on the top and a complicated expression on the bottom, it's much easier to simplify everything before you actually divide. All right. Let's see. Okay. Okay, let's do one more example before we start the Kahoot. What over here we have use the formula at the left to find Kaylee's minimum training heart rate if she is 15 years old. Okay, so we have some interesting information here. This is formula. Athletic trainers use the formula 3 times 220 minus A divided by 5, where A is a person's age, to find their minimum training heart rate. Okay, can I have an example? So Jason, can you tell me how old you are, please?
Like a random number.
No, like how old you actually are.
11.
11? Okay, so I'm going to write this expression on the whiteboard. We have 3 times 220 minus A, which is the age, divided by 15. Or was it divided by 5? Sorry. So this is the formula. This is an A, not a 9. I can probably write this as
We do the brackets first.
give me a second. So you said you were 11, right, Jason?
Huh?
So your age is
So
11.
220 A equals 11, and then
So A
220.
is 11. Okay,
So
so
220
let's take
minus
this one step at a
11.
time. Let's take this one step at a time. We substitute the value in, right? We'd have 3 times 220. Can you guys please not scribble on the screen, please? Thank you. So we have 3 times 220, and then I know this may seem unnecessary, but we can throw an extra bracket in here to show that
Yeah, I
we
know.
substituted the value in, right? So we have 3 times 220 minus 11. And what is 220 minus 11, Jason?
I mean 119, 219. I mean
219?
Yeah.
This is 11.
what?
This is 11. 220 minus 11.
Oh, 209.
209. Okay, so we have 3 times 209 divided by
I thought
5.
that was a 1.
Nah, it's an 11. You're 11, right? I don't think you're 1 year old. So
It's
we have
209, right?
yes, it's 209, not 219. So now we're at 3 times 209. William, can you tell me what 3 times 209 is, please?
3
William,
627.
627?
627.
Okay, I'll take you at it, Jason. So
Because 6
Six
times 9.
27.
627, thank you.
6 times 9. 3 times 9 is 27. And then
Mhm.
3 times 2 equals 6. Then we
Yes.
add them up. It's the 627.
Exactly. And now 627 divided by 5. I think Ryan is already writing out the answer. It does look to be 125.4 because I know 5 cubed is 125 is 625. So this looks correct. If you write it, you can write it the way Ryan did, or does anyone does anyone in the chat or does
It's
anyone know how to write it?
125.4 because when you do 125, it will be like
You'd have
600.
2 remaining. Exactly.
Yeah, we have 2 remaining, but then 20 and 2 you can bring down a 0 equals 20, and then 5 divided by 20 equals 4, and then 4
Exactly.
5 times 4 equals
Okay, so for you, Jason, for you in particular, I think most of you are probably around 11, 12. You guys would have, I think it said here in a minimum training heart rate of 125. We can keep it at a whole number, about 125 beats per minute. So what that means is like when you're running or something, like when you're actually like doing exercise, your heart rate, if you're measuring it, it should be at about 125 beats per minute. If it's any lower, it might be a bit dangerous. I'm not too sure. I'm not like medical personnel, but it's interesting to know. Okay, this is practical information. If you grow older, like for me, okay. Let's use my age as an example. I'm currently 17. If you guys want an easier age, I can round that down to 15. That's my sister's age. Let's try 15. So, someone other than Jason or Ryan, Ray, would you like to try what the answer would be if A is equal to 15? Okay, so our expression here is 3 times 220 minus a over 5. So can you calculate this, please, Ray?
3 times 210.
Okay. Why is it
That's
210?
huh?
So a is 15, remember?
Yeah.
So we have 3 times 220 minus a, and a is 15.
3 times 220 is 660.
Okay, so remember, our first step is to substitute 15 into a, right?
Yeah.
So what would you do next? You have 3 times 220 minus 15 divided by 5. I'll write the ones with the tail and the head. What
3
do
times 3 times 220 is 660, right?
I think you're using the distributive property, but let's not go there yet. Just try evaluating the numbers inside the brackets first. Because I know the distributive property, it might be useful sometimes, but the numbers might cancel really nicely before you do the multiplication, right? Because multiplication, it can be harder if you just do the subtraction first. So can you do 220 minus 15 first, please, right?
That's 205.
205, okay. 205 multiply 3 divided by 5. What can you do next? What's next, right?
What?
What's after? So 3 times 205 divided by 5.
So 205 divided by 5 is
Oh, you could do that, or you can do the multiplication. So in my opinion, I think doing the multiplication isn't that bad. You can do, what's 205 times 3?
615.
615 divided by 5. We can do the long division over here. So we have 615, have a 5 on the left. What goes above the 6? We can try a 1, right? Try 1. 1 times 5 is 5. Then what do I throw down here? Right? Right?
What?
So we're doing 615 divided by 5.
I haven't done long division in a long time.
Okay, well, we can do a review. So if we have 615 and then we divide that by 5.
Can I help?
Go ahead, Jason.
It's 1, 2,
You can clear the
3.
screen first.
Yeah, I already did that.
Okay.
It's 1, 2, 3. Can you help me write it because mine
Sure.
is too big. One. Can you put one like one down, like 6 minus 5
Okay,
equals
so
1, right?
let's start at the beginning. So 615 divided by 5. The first guess would be a 1.
5 can fit in 6 one time, so we write
Exactly.
a 1.
So we throw
So-
a 1 at the top, and
And
then
then we write a 5 under the 6.
so why so? Well, why is it a 5 and not a 10 or something else?
Because if 5 times 1 equals 6.
Exactly. So 5 times 1 is 6, and then what next?
And then we bring down the extra 1. Bring
So
down the 1 because we subtracted 5 minus 6.
exactly. So 6 minus 5 is 1. We bring the rest of the stuff down, so we have 115.
Wait, we don't
What do we do
write the 5. I mean, we could write
Oh,
the
okay, we could, but okay, fine. I'll just drop down the 1. So what about 11 divided by 5? How
And
many?
we put 2 because
We can
that's
put
the
2.
only thing that fits. And
Right,
that
so
equals
10 goes
5
in.
times 2, 10.
So we can subtract the 10, and then
And-
what we have next.
And like 15 because that 15.
Okay, we drop down to
add-
1. We get a 15,
And then that's a 3. 5
that's a
times 3
3.
equals 15.
So
Oh.
5 times 3 is 15. 15 minus 15 is 0, and we have no remainder. So
Voila!
finally, 615 divided by 5 is equal to 123. What a nice number. So if you do grow up to be 15, your resting heart rate, well, your minimum athletic heart rate should be 123 beats per minute when you're doing exercise. I guess it's pretty interesting to know. Basically, the older you go, I'm pretty sure the lower it'll get. So don't be too surprised if you're like really old and it's like really slow. But we'll see. Let's start the Kahoot if you guys have participated, joined it yet. Let's make this fast, please. I'll start in another minute because
Well, I'm almost finished.
we'll have time.
All I can say is pi is like infinite.
Oh, it's not infinite. It's an irrational number, but
Pi is infinite because it's like so much decimals.
well, I think we will need to have a lesson on that sometime soon, Jason.
Because it's
You'll see
basically
whether you're right or wrong. I'm not gonna spoil too much now, but we'll definitely cover it. We'll definitely cover it.
Because after a while it's only like 10, like those 10s, 20s, 30s, 10s, and 7, and then it's 22 divided by 7. So you can't really do much.
Well, I'm not gonna say anything. Shall we begin? Is everyone in?
Not yet.
Yes, sir.
My name, I don't know why, but then the name isn't loading in.
Okay, well, I'll copy the link into the chat.
Oh, it works. It works now.
You're in? Okay. Let us begin. Skipping. All right. So if you do plug it in, 2 times 3, remember it's multiplication first, bedmiss. 2 times 3 is 6, so 15 minus 6 is equal to 9. It's standard, just doing math. If you rush, you might have chosen false, but if you took the time to actually do the math, you should have gotten 9, right? Good job, guys. But don't rush. That's my point here. It's testing concepts. Nice. So we see that an algebraic expression should contain only numbers, variables, and at least one operation. If it's just like 2x, that's not an algebraic expression. If it's like 2x plus 5, then that is an algebraic expression. Right? Let's move on. Job top G. What is a variable? Nice. So we see that a variable, it's a symbol. Remember, it can be X, it can be Y, it can be a cupcake, it can be a star. Most people like throwing in an X. It's a symbol that means something unknown, right? It's not an expression. An expression has a definition of its own. And I'm glad that, well, it's definitely not a branch of mathematics.
It's 7 o'clock.
And I'm not too sure why you would choose green. It's a bit sketchy there, but just remember a variable, think of X, all right? Variable is X, something you don't know. Let's move on. Okay, shall we move on? Okay, good job. it should just be 6 plus 8. I think blue was a misclick, or maybe a miscalculation, but good job. Ah, we talked about this. So in case you guys don't know, omitted means removed or not written. Okay, it is true. Remember, we talked about this. Multiplication sign, we write as a dot, or we just don't put it at all. Okay? Keep it up. Well, coefficient is the numerical part of the expression, the number part, not the letter part. Okay, skip. It is 7, because 7x has the 7 in front of it, so we know the coefficient is 7. I'm skipping. All right, I think everyone got that one right. Take your time. Okay, I'm skipping if, oh, okay. It is 2. 2 times 7 is 14, minus 2 times 6 is 12. 14 minus 12 is 2. So the answer would be 2. Double points. I think there are 2 answers here. Might not be multi-select, but one of them isn't as obvious. Take your time, guys. Wow. I'm not too sure why you guys would choose red or blue, but if you do calculate them, I'm pretty sure red would be 21 minus 9. That's like somewhere in the 15-ish region. And then we have 9 minus 10, which is a negative number. So both red and blue, I think, are wrong, while yellow and green, they should be the correct ones. Just remember, don't rush. If you see lots of variables like this, just plug them in. You had a minute on the clock, so just make sure you don't, especially on a test, you don't want to plug random numbers in and then get random numbers out. That's the expression. Fill garbage in, get garbage out. So okay, so the answer is sometimes. The reason why it's not always and it's not never is because x and y, if you can just plug some values in, right? If you
What
say
if x is a different value?
exactly, that's why it's sometimes. If it's, let's say x is 10 and y is also 10, then both of them are 10 minus 3, they're 7. That means they're the same. But what if 10 is like a million and y is 0? Then obviously the two values are not going to be the same. So it can't be never, but you know, if x and y are the same, then x minus 3 and y minus 3 are the same. So sometimes would be the answer. It just depends on what x and y themselves are. Okay?
I misclick to never.
Ah, okay. Well, let's look at the leaderboard. Drumroll, please. Top G. Job. I think he dominated the new leaderboard for quite a bit. New Muffin. Job, Jason.
That's me.
And first, we have Ed.
But how do you know it's me?
Sunglasses. Well, I think you were the last person to join, so kind of gave you away. But good job to everyone. Round of applause. I'll see you guys all next week.
Okay, bye.
Hi, Jason.
Bye.
See you.
See ya. Bye, Ryans. Nice weekend and week.